Everything you know about shooting stars is a flat-out lie. This cosmic rock is moving at 40,000 miles per hour, but it is not burning because of friction. If you think air friction destroys asteroids, your school teacher forgot to explain the brutal physics of extreme ram pressure. When a giant space rock slams into our upper atmosphere, it goes from a pure vacuum to dense gas layers in less than a millisecond. The air in front of the rock literally cannot move out of the way fast enough, creating an instant wall of ultra-compressed gas. This radical compression raises the local temperature to 10,000 degrees Kelvin, melting solid iron into liquid space rain. This means the asteroid is not rubbing against the air. It is being crushed to death by a supersonic piston made of pure oxygen and nitrogen. Every single second, our planet is bombarded by 100 tons of space dust. Yet you're still alive because of this gas wall. The atmosphere acts as a hyperreactive explosive shield that triggers a kinetic detonation before the cosmic threat can touch the ground. But the trillion-dollar question is what happens when the gas wall fails to break the intruder apart. Most cosmic destruction happens exactly 50 miles above your head, in a specialized atmospheric dead zone called the mesosphere. At 11 kilometers per second, the air acts like a solid concrete wall, transforming kinetic energy into pure thermal chaos. The pressure builds up so heavily on the front nose that the rock structure undergoes massive mechanical failure and shatters. This sudden fragmentation multiplies the total surface area instantly, leading to a catastrophic mid-air explosion called a bolide. This is exactly what saved humanity during the famous Chelyabinsk event, when a hidden mountain exploded safely in the sky. Out of 50 tons of daily space debris, only tiny fractions survived as literal hellfire to become collectible meteorites on the ground. If a space rock enters at a shallow angle, it can bounce off our atmosphere entirely like a flat stone skipping across a lake. This means angle of entry is more critical than the size of the asteroid itself when calculating global doomsday scenarios. To predict if a space rock will kill millions or just dissolve into dust, we must look directly inside its chemical core. 95% of all cosmic objects tracking toward Earth are chondrates, which are basic stones made of weak silicate minerals. These stones are structurally pathetic. The moment they hit the extreme plasma wall of our atmosphere, they explode like cheap dynamic bombs. But the remaining 5% are cosmic nightmares made of solid nickel iron, forged inside the dead cores of ancient shattered worlds. This metallic armor behaves completely differently. It laughs at the atmospheric shield, easily slicing through the thermal barrier without breaking. When a solid iron block hits the ground at supersonic speed, it creates catastrophic craters like the famous blast site in Arizona. The real danger is that modern satellite tracking systems are practically blind to smaller iron rocks approaching from the sun's blind spot. If an iron meteorite measuring just 30 meters wide strikes a major metropolitan area, the city center instantly vaporizes into pure heat. To survive this cosmic assault, Earth uses a hidden physics mechanism known to aerospace engineers as thermal ablation. As the space rock melts at 10,000 degrees, the high-speed airflow instantly strips away the liquid outer layers of the rock. This constant stripping action actually removes the heat along with the melting material, protecting the freezing cold center of the stone. Inside a burning meteor flying through plasma, the temperature remains deeply frozen at minus 200 degrees Celsius. It is a literal paradox, a piece of ancient space ice wrapped inside a raging fireball, screaming toward the surface of our planet. But if the ablation process is uneven, the rock becomes aerodynamically unstable, starting a violent spin that ends in absolute destruction. The air pressure differences between the front and the back of the spinning rock create a vacuum that pulls the stone apart from within. This mechanical stress triggers an instantaneous release of kinetic energy, equivalent to multiple tactical nuclear warheads detonating at once. Because survival is so rare, the fragments that do hit the ground have created a multi-million-dollar underground economy. Private collectors and elite black market dealers pay up to $10,000 per single gram of rare iron palladides. These pieces are older than Earth itself, carrying pristine chemical elements from the very birth of our solar system. Every shooting star you see is a brutal physics masterclass, a violent fight between extreme speed and atmospheric defense. Understanding these invisible cosmic laws separates the average observer from the elite minds, who control the future. With every single video of mine, you will get smarter and smarter every day,